Welcome everyone to another Khan Academy tutorial. I am Mr. West and this is West Explains Best. We're doing constraint solutions of systems of inequalities today. This is a really good one for practice and understanding systems of inequalities. Really makes you understand what it's talking about and what is deemed a solution. So let's go ahead and get right into it. Which x values make the ordered pair x, negative 5 a solution to the system of inequalities represented by the graph? Okay, with this, we first need to understand what this is talking about. Okay, we're talking about any point, okay, any point that has negative 5 as the y-intercept. Not the y-intercept, but the y value. Okay, so we know our y value is negative 5, but we don't know our x value. We get to pick our x value so that this becomes a solution. So we need to talk about what is a solution to this system of inequalities. We have two different graphs here. Two different linear inequalities. One, we have a boundary line here, okay, and it's shaded below. We can actually easily come up with the equation of this one if we wanted to, and I'm not going to do that for this video, but if we come to it later on in this video, maybe I'll talk about it. But for this one, we're just trying to figure out what does it mean to have a solution, okay? And this one, we have a solid line and it's graphed above. What are you talking about with with the solution to a system is where they overlap. So we're looking for the overlap with these. So it's everywhere in here. Okay, now we're asking ourselves, okay, which x values make the ordered pair a solution? So there's a range, okay? There's a range of answers because there's a range where these overlap. Now, it's asking us for a specific y value, so we need to determine what is the y value that gets paired with the x values. Well, we already know the y value is negative 5, so we're going to mark negative 5 here. And so we're going to follow this along, and we're going to see what x values along this line, y equals negative 5, makes this a true statement. So we're looking here, what are the x values? Well, the x value starts here, and it goes to here inside this overlap. So what are those numbers? That's 7 and 2. Now, keep in mind this, though. At 2, it's a solid line, so it can include 2. So x can be equal to 2, but it has to be bigger, okay? Now, when we're talking about x values, okay, if we're moving to the right, x is bigger than whatever that value is. If we're moving to the left, it's smaller than those values. Okay, so if we're looking here, notice how x can't be bigger than 7. As we get bigger than 7, we're off the graph here to the right. We don't want to be bigger than 7. We want to be less than 7, but we want to be bigger than 2 because as we move to the left of 2, it's not included in the graph, in the solution where there's overlap. Okay, now look at where x is 7. Okay, so this was the point, by the way, this was the point 2, negative 5. So we know 2 was included, and that's why we wrote that. Now let's look at 7. Notice how it's a dotted line. It can't include 7. It can be smaller than 7, but it can include it, and that's why we use that less than sign. Not less than or equal to, but just less than. There's the warning bell. Okay, so we were looking for, did I get that right? Oh, that's not 2. This whole time I was thinking it was 2. It's 3. Why did no one say anything? Okay, so this is actually 3. I'm sorry. I wrote on it and couldn't even see. Okay, so we're looking at the values that are greater than or equal to 3, but also less than 7. So there we go. Those are solution. All right, let's go to the next one. Now that you got the idea, we'll probably make this a little bit easier. Okay, now we're talking about the y values that make the ordered pair 0, y a solution. Now we're just going the opposite. We're flipping it. Okay, so we already know our x value. Our x value is 0. Where is x equals 0? Well, x equals 0 right there. So we're looking at this little slice here. That's everywhere where x equals 0. But now we need to find the y value that makes this true. Well, let's look at the solution. The solution is this area right here where there's overlap. So the y value crosses that line, x equals 0, and the solution at those two places that I marked in red. Now, this point right here is the point 0, negative 2. Let's take a look at it. It's a solid line. That means it can include negative 2. Does the solution, the overlap, go below negative 2? It does not. So y needs to be greater than -2, but it can be equal to because it's a solid line. Okay, now let's look at the top portion. This is our upper limit. It's a dotted line. Okay, notice how the solution, the overlap, doesn't go above, let me use a different color. Notice how it doesn't go above that spot because it's not a solution. Therefore, we're stopping at y equals 3. But it can't include y equals 3 because it is a dotted line. So that is our upper limit. So we're looking for -2 is less than or equal to y is less than 3. And that is here. Check it. Okay, now we have which x values make the ordered pair x -7. So now we're doing it again the opposite. We're flipping it again, and we're looking for y equals -7. Okay, so there's y equals -7, and we're just going to extend this line. Okay, and we're going to stop at where there's solutions. Okay, because over here there's no solutions. Over here there's no solution. Okay, so we're looking for the x value. X values are left and right. Now, let's look at where it stops. So it stops here. Notice how it's dotted. It stops here. Notice how it's dotted. Okay, so we're here and here. So -4 is the furthest it goes. This is the point. -4, comma, -7. Remember, the y value is -7. Here is 2, comma, -7. Okay, so -4. It can't include it because it's dotted, so we're less than. Okay. -7, it can't be bigger. That's not a solution, so it has to be less than, what is that? Oh, sorry, that's 2. Past 2 to the right is not a solution. Past -4 to the left is not a solution. So it's going to be somewhere in there, but it's not including those extremes, the endpoints, the upper and lower limit, because it's a dotted line. So we're looking for -4 is less than x is less than 2. Bingo, letter C. One more. Let's see if we can do this one quickly. Okay. We're looking for the y values. Again, we're talking about vertical, so we're looking for the x value of 4. Here it is. And we're going to go up until, boom, there's our boundary. There's our boundary because, remember, this is our solution in there. I want to erase it. It's all ugly. But that's our solution. Everywhere there's overlap there. So we're talking about this vertical distance is part of our solution. Okay, let's look at the lower limit. Notice how it can't go below that line, wherever that is. That point here is the point 4, comma, what is that, -1. So it can't go below the y value of -1. So it has to be bigger than -1. Can it equal -1? No. It's a dotted line, so its y is greater than -1. Let's go to our upper limit here. What's that point? That point is 4. Again, the x value that we've been given. And then 3. So the y value is 3. Okay, can it include 3? Yes, it can. So we're going to do less than or equal to. Notice how it can't go above that line. That's why we have to have y is less than that. Y is below, y is less than that. So our answer is -1 is less than y is less than or equal to 3. Trying to trick us here. It's trying to trick us here. This is the answer. All right. Hopefully you'll be hearing this sound of success. Thank you so much for watching. I'll see you next time.